Good day, Doctor. I'm Ting E, AE230061. We are from Group 9, Section 2. Today, we would like to present off-grid renewable generation system for a residential house. This is my team member, Nyak Nadia, Philomena, Siti Maisara, and me, Ting E.
Hi and Assalamualaikum. My name is Siti Maisara binti Atofadi and my metric number is TE220010. So now I would like to present about our project entitled Off-Grid Renewable Generation System for a Residential House. So first, abstract. This project presents the complete design and evolution of an off-grid solar photovoltaic system for Merdeka Mustaq residential house. The project begins with a detailed load assessment to determine the total energy demand, maximum demand, and design current. Based on this calculation, an off-grid system consists of eight 519-watt PV module, lithium-ion battery bank, and a 3 kVA inverter was designed. System performance, economic feasibility, and environmental impact we then evaluate to verify the sustainability of the proposed system. So next, introduction. This project focused on designing an off-grid renewable generation system specifically of a residential building. Unlike general renewable study, this project is based on the actual electrical load profile of Merdeka Mustaq House. This system design include load calculation, selection of appropriate protection device such as MCB, RCCB, and proper sizing of the PV array, battery storage, and inverter to ensure reliable and continuous power supply. So now about problem statement. Currently, Merdeka Mustaq relies entirely on conventional grid electricity. This dependency exposes the household to rising electricity tariff and possible power interruption. Without any backup or renewable energy system, the house lacks energy, autonomy, and resilience. Therefore, a technically justified off-grid renewable generation system is required to meet the house's daily energy demand in a reliable and sustainable manner. So the main objective of this project are to perform accurate load calculation, design a sustainable off-grid photovoltaic system, and select appropriate protection device. In addition, the project evaluates the economic feasibility and compare the environmental impact of the proposed system with conventional power generation. That's all from me.
Hi, my name is Nadia. So I will continue for the documentation. This is the floor plan of Pendeka Musta House. So I will continue for the load calculation analysis. The total connected load is 3761 watt. Total maximum demand 2785 watt. Consider factor 0.9. Final maximum demand 2507 watt. And the maximum current is 12.8 ampere. So for the recommendation of circuit breaker, the first one is miniature circuit breaker MCB based on the calculated design current of 50 ampere. 20 ampere single per MCB is selected. So the second one is residual current circuit breaker RCCB. 40 ampere, 30 milliampere RCCB is selected for this system. The 30 milliampere sensitivity ensures protection against electric shock, while the 40A current rating is stable for the overall load. So this is the off-grid PV system design. So the first one is solar panels generate DC electricity, and then a charge controller regulates power flow, and then energy is stored in a battery bank. And the last one, an inverter converts stored DC into AC for household appliances. So for the solar PV panel dimensioning, so the maximum power is 590 volt. The open circuit voltage is 52.63. The short circuit voltage is 14.13 and the module efficiency is 24.8%. So next is the sizing of inverter. The nominal AC output power is 4000 watt. The rated input voltage 330 volt DC. The maximum DC input voltage is 550 volt. MPPT operating voltage range is between 90 to 550 volt. The number of MPP input is 2. The maximum current per MPPT is 16 ampere. And the last one is AC output voltage and frequency is 230 volt and 50 hertz.
The battery bank that we use is with the nominal voltage 51.2 voltage and with the nominal capacity 800 ampere h, and our temperature fixed for the battery is 20 degrees Celsius. For the system monitoring, we use Fusion Solar to monitoring and ensure the reliable operation evaluates all the performance of the residential PV system. The picture show is our PV system prototype. We chose off-grid solar PV system. This is because it can provide the electricity independently from the main power grid, making them suitable for our rural area. This solar panel generates DC electricity, which the calculate by charge controller that store in battery, and the inverter will convert the DC to AC that can use by household. This system is environmentally friendly and offer reliable, independent, and cost-effective energy. Our block diagram is the PV modules will supply the energy to the DC combiner box DCJB, and after that DCJB will send the energy to string inverter, and string inverter will transfer the power to the AC main switchboard is MSB, and MSB will transfer the power to existing distribution board, and this board will transfer this energy and supply the energy to the household load. Then the MB meter we use in our Fusion Solar monitoring. We monitor this, and we can monitor this use the mobile app such as the website. We also calculate the estimation of energy consumer. The total bill for the energy consumer that we estimate is 155.95 The capital cost estimation for this PV system is we use 8 unique PV panel that can cost 500 per unit with the total 400, and for off-grid inverter is for 1 unit is 4,000, and mounting structure and cable is 3,500, and the installation and labor cost is 2,500. That can total cost of this is 14,000 ringgit. The economic benefit of this purpose of solar PV system is evaluated by comparing the system installation cost with the estimated annual electricity saving. Assuming the solar PV system offers a significant portion of the annual electricity consumption, the estimated payback that we get is X.3 years.
The total, I'm Ting Xin E and E2300061. Today I would like to present about the discussion. So the design calculation confirm the feasibility of implementing an off-grid photovoltaic system to meet the household daily energy consumption. So the number of PV panels which we use at panels with 590 watts, so the total installed PV capacity is 4.72 kilowatt peak. So for battery bank, we use 4 battery bank with 51.2 volt, So the total storage is 20.97 kilowatt per hour. So for the inverter, we choose 4 kilowatt, which is single phase that's suitable to meet the maximum demand of 2.5 kilowatt. So for solar charge controller, we choose 150 volt and 80 ampere. It depends on the series of parallel configuration. So the off-grid system is designed to provide one-day autonomy, and it's supplying continuous electricity during the peak of low solar irradiance, and proper battery sizing, depth of discharge, and overall efficiency to ensure the reliable performance and prolong the battery lifespan. So for energy efficiency, the air conditioner are used selectively in the living areas and bedrooms to optimize the energy consumption. So for the ceiling fans, it provides the cost-effective cooling when aircon units are not in use. So for LED bulbs and fluorescent lamps are installed according to the standard practice to balance the lighting needs and energy saving. So for the appliances with continuous operations such as refrigerator are chosen for low power consumption while maintaining the performance. Next is the key performance. The key performance metrics for the design of grid PV system are as follows. So the performance ratio, which equal to actual daily energy consumption divided by the theoretical energy consumption, which is PV module power times the peak sun hour times the system efficiency. So it is 15.1 over 4.72 times 4 times 0.8. So we get 15.1 over 15.1, so it is equal to 1, which is 100%. So for the solar fraction, it is energy supplied by the PV over the total energy consumption, which is also 15.1 over 15.1. So we also get 100%. So for the performance ratio and the solar fraction values indicates that the PV system is sufficient to meet the household energy and the demand entirely under the typical condition. So minor efficiency losses due to the temperature or inverter conversion are accounted in the system. So it besides that, they got a annual performance ratio trend graph. So in this figure, it show that the annual performance ratio trend of the off-grid PV system. So the performance ratio remains 100% throughout the year, which indicate that the design PV system is capable of meeting the household energy demand under the typical operating conditions. So this reflects that appropriate system sizing with losses is due to the temperature, wiring, and inverter efficiency that already considered in the design. This is the infographic comparative study between the conventional power generation and off-grid PV system. So for the resources, the conventional power generation use the fossil fuels such as coal, oil, and natural gas, while for the off-grid PV system, it use the solar energy, which is more eco-friendly. So while for the carbon footprint, the conventional power generation will release the greenhouse gases such as carbon dioxide and air pollutants such as sulfur dioxide and nitrogen oxide. So for the off-grid PV system, there is almost zero carbon footprint during the operation. While for the pollution, the conventional power generation will cause the air pollution, water pollution, and thermal pollution. While for the off-grid PV system, there is no any pollution during the operation. While for the ecosystem impact, the conventional power generation will harming the aquatic life. While for the off-grid PV system, there is no ecosystem impact. So in conclusion, the design of grid PV system can fully meet the daily energy needs of Pendeka Musta house. So the system uses 8 times 590 watt solar panel, 4 lithium-ion batteries, and 3 kilo inverter, which provide reliable power with one-day autonomy. So although the performance ratio and solar fraction are idealized at 100%, but the system losses are considered in this design. So this system offers the environmental benefits, low maintenance, energy independence, and long-term cost saving. So for overall, this off-grid PV system is practical, sustainable, and reliable solution for residential energy supply.